Okay, 350. The previous video should have gotten you up and running in terms of having a virtual box, being able to use it. This video is, I'm just going to go over once you've started working on the code, how do you test it? How do you figure out if things are working the way they're supposed to work? And sort of what is the coding flow for this assignment? I'm going to be working with finished code for this assignment, so I'm not going to dig too much into what it should look like, what it shouldn't look like, because I don't want to show you too much about the final solution. So I'm just going to pop this into full screen mode right off the bat. Um, so if you've never used Terminal before, highly recommend using it. Just getting used to it. It comes up a lot in Penn engineering classes. So just as a reminder of how you get to it, I'm going to open up Terminal. I installed, so in the Sublime editor is default on this installation. I went ahead and did sudo app get install. I did tree. I also did tmux. These are two utilities that I just want to clarify you don't need to be able to do this assignment. I'm just going to use it to try and for the purpose of this video. So don't feel like you need to get those or know what I'm doing to do some of this stuff. So I'm just going to do ls. I saved it, I think, to downloads. Lab 4, group 10. And this is my emulator code. In the starter code, I believe we gave you. Let's see. So in the emulator starter code that we gave you, we basically just give you the bare bone C files, and in the README, if we just do cat README, you can see we just say these are some ways you'd want to compile the project. Now, if you're familiar with makefiles, you might want to go ahead and make a makefile for this project. If you're not familiar with makefiles, feel free to just write down all of the compilation steps you need. Basically, what a makefile is I can show you mine right here. Oh, this doesn't have Vim installed yet. Interesting. So I'm going to open up in Sublime. And this is my makefile. This is way more complicated than it needs to be, but basically my makefile, this is not part of the assignment. If you want to just have a txt file with a bunch of, with each line of code you need to use, feel free to do so. I'm just using this makefile, and what it will do is it will look through all the source, all of the C files in the source folder. It will compile each of them, link them together, make them into object files, link them together, and then put all the object files in the object folder, and then the end result will be put as executable. So, and I can make sure if you're using GCC, if you're using a makefile and you're not using actual just GCC, always remember to make clean or remove all of your object files beforehand. So I've written my makefile. I can just make it. It will go through. It's going to complain to me because I wrote some C code that I think used a problematic function, but I'm going to go ahead anyway. And let's get rid of this one. It's X. Yep. Okay, so I'm going to go ahead and I'm going to launch this executable. Now, the way I've written this executable, it's going to start off the bat, it's going to display this welcome screen, and it's going to ask me which file I'd like to load. So you're going to need to load in files. These are going to be bin files. I'm going to there we go. So I'm going to show you where I keep them. So in the games folder, I'm just going to go tree games to show you what the content of the games folder is, and it is the following bins. Each of them are slightly different games. Some of them are more complicated than others. Most of these games are going to be using a lot of, actually, I believe most of these will be using almost all of the assembly code. So there's kind of, when you start trying to go through the ISA, it's going to be a little bit intimidating because you have a ton of different ISA instructions you have to go through, and there's not really a great way to test it. What I would highly, highly, highly recommend doing is just write your own ISA. Do a little demo program, maybe just test one ISA instruction and just check, use print statements to print out the values of every register just to make sure that that one ISA instruction works. The games are for the final, like when you've finally gone through everything and you want to check to make sure everything works, you can use these games. That being said, there are a couple games to keep mind of. So I'm going to show you, let's see if I go subble games/maze. So this is the maze game. It's very short. It's only a handful of lines of assembly, ISA, and you can go through it. Each of these blocks right here represents a 16-bit ISA instruction. So you can already get off the bat that it's relatively easy to walk through. There's only a handful of them. I would highly recommend as an exercise, look at this, write it out as assembly, write it out in terms of like pseudocode, what it's doing. You can pause the video if you want to try and figure out what this is doing. I'm going to go ahead and run this in my emulator. So I'm just going to go over to this. I'm going to load games/maze. And the maze game is going to pull up this. So this is the desired result of the maze. The program itself is not, it doesn't accept any input. It's not an actual maze if you're looking for a game where like you can move your cursor through the maze. That's not what this is. It's just going to draw a pattern. It's going to be a repetitive pattern. What that means is you can use this game as a quick test as soon as you have all of your basic ALU instructions. Those are your ands, your ors, your control flow statements, your ifs, all of that, and you have the ability to draw pixels. You can start to test this. This game will not work if you don't have the drawing pixel function enabled. It's kind of an annoying one to test, but I highly recommend doing it. It's very useful in terms of it uses addition operations and control flow operations, so you can really easily see where you're messing up early on. As a result, I would recommend probably the first thing you want to do is be able to make sure that you can draw pixels on screen to a specific location, and then get started on your ISA, because this is one of the first games you're going to want to get off the bat. This does not make sound. It doesn't require input. When you start wanting to mess around with requiring input and making sound, that's when you're going to want to move over to things like missile. So I can quit out of this, go executable, makes a little blip. I can go games, missile, say it, and I can get this. On my computer, this is very fast. Originally, when I developed it, what is it? Am I supposed to click? Okay, so I'm clicking A. It's going to say 20. Okay. Anyway, so as you can kind of see, I developed this on a slightly slower computer, so I have a sleep timer in there to try and tell it how long a click should be. A better way of doing this would have been to just measure the time difference and have a custom delay that just makes sure that the refresh rate is at a fixed hertz, but that was a mistake on my part. We will not penalize for a too quick game or a too slow game. But this is an example of it's a game, it requires input, it requires addition, subtraction, multiplication, division. There's control flow statements, it's drawing numbers to the screen. And then if you want to, sort of the final game I would recommend testing with would just be Pong. This is going to freak out because I'm going a little too quickly. And you have to type your keys into this. Yeah, it's been yeah. Yeah. So this is just going to go back and forth in Pong. This is a good one to test for sound because you'll hear the sound right off the bat. Once you've tested all of these, you should be fine if it works. And that's sort of how you would go about testing with a game. Just sort of a reminder, you can also just test normal ISA instructions really easily by just writing your own bin files. So if you want to specifically test control flow statements just to make sure the right control flow's done, you can do that. And then you can also feel free to, I don't know, dump the register, just print out all your registers at the very end, and that should work for you. Let me know if you have any questions, but that should hopefully have you set up for the debug portion of this project.